Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing the remainder theorem, the factor theorem, and factoring polynomials. So the remainder theorem is a theorem that basically just says that if you have a polynomial, which we're going to call f of x, and we're dividing it by x plus c, so a polynomial specifically of this type, so something of the type that we also had for synthetic division, which is no coincidence, for some constant c, then the remainder is equal to f of negative c. So all you have to do is actually take the opposite of this, so the negative c, and plug it in to get out what our remainder is, without actually doing any division whatsoever. So let's look at an example that we already know. So we found that the remainder when dividing, so we want to try to find the remainder when dividing x to the fourth plus 16 when it is divided by x plus 2. Well, we know the answer was 32 because we just did this example in the previous lecture. But what would happen? Well, if we're trying to use this idea. Well, instead of x plus 2, we're going to try to plug in negative 2. And we're going to plug negative 2 in to this polynomial. So negative 2 to the fourth plus 16. Well, negative 2 to the fourth is equal to negative 2 times negative 2, which is 4, and then times negative 2 is negative 8, times negative 2 is positive 16, and we get the familiar 16 plus 16 equals 32, so which is the remainder. Which is what we know. So, so we've confirmed this. So what does this actually mean? So it's actually kind of cool because the remainder theorem really just leads into what we call the factor theorem, which is more or less the same thing, because we know when the remainder happens to be 0, we know that what we divided by goes into it evenly, which means that it is a factor. And the quotient is also then a factor if it divides into it evenly. So the factor theorem, which is basically the same thing as the remainder theorem, just says this, that if you try to find the remainder and it equals 0 so f of x is a polynomial and divided by x plus c for some constant c, x plus c is a factor if when you plug it in you get out 0. All right? So with that being said, if we want to determine if x minus 1 is a factor of x cubed plus 5x squared plus 2x plus 8, so if we call f of x equal to x cubed plus, actually just give it a name, that's all we're doing here. Could have done that from example 2 if we wanted to. And what do we have to plug into f to actually see if x minus 1 is a factor? We have to change the sign. So we have to plug in f of 1. If we plug this in, we get 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. 1 cubed is 1. 1 squared is 1 times 5 is 5. 2 times 1 is 2 minus 8. 5 plus 1 is 6. 2 minus 8 is negative 6. So equals 0. So when we plugged in 1, we got 0. So is x minus 1 a factor of this? Yes. X minus 1 is a factor of our polynomial given by f of x, because the remainder was 0 from the remainder theorem. All right. So what about this? Is x plus 3 a factor of this? Well, let's give this another name. Let's call it g of x. So if g of x equals 2x cubed plus 5x squared minus 6x minus 7, is x plus 3 a factor of g of x? Well, it is a factor if when you plug in, so here we have x plus 3, we need to plug in negative 3, so the opposite of whatever this is. If this equals 0, then yes, it is a factor. But what is it? Well, it's 2 times negative 3 quantity cubed plus 5 times negative 3 squared minus 6 times negative 3 minus 7. And when we compute this, we look at each term. Negative 3 quantity cubed is negative 27 times 2 is negative 54. Then again, we always do the exponent first, then we multiply. So negative 3 cubed is negative 27 times 2 is negative 54. Negative 3 squared, which is positive 9. Negative 3 times negative 3, negative negatives is positive, times 5 is 54, or 45, excuse me. So negative 54 plus 45, negative 6 times negative 3 is positive 18, then minus 7. Negative 54 plus 45 is negative 9. 8 minus 7 is 11. Negative 9 plus 11 is 2. Did this equal 0? It did not. So no, x plus 3 is not a factor of g of x. All right. So why is this important? Well, it allows us to quickly determine if something is a factor without going through the full division. Sometimes, especially if synthetic division is allowed, this is actually, it's almost quicker just to do the synthetic division. But in more complicated cases, sometimes, especially if we don't want to do the synthetic division over and over and we can quickly compute this might be a better idea. But the whole point of all of this, coming back all the way from 4.2, is how can we find the x-intercepts and the zeros of a polynomial if we don't have a method to fully factor? Well, we now do have a method of factoring, and that's division. Okay, so we know if something is a factor if it's 0, or if we have a remainder of 0. And so we know that if it goes into it evenly, so if we have a remainder of 0, then what we also have is that the divisor and the quotient are both factors. So let's take a look at this example. So if we have f of x equals x cubed minus 3x squared minus 6x plus 8, and if we're and we know x minus 1 is a factor of f of x, so we already know one factor. Okay, so that's the sort of limitation that we have so far in this section. We have to know what one of the factors is, so which we could guess by using the factor theorem, but still that requires some guessing. How could we find the full factorization? Well, we can divide. So x minus 1 is a known factor, and so we're going to divide. You can do polynomial division, but x minus 1 is satisfies the form for synthetic division. So we're going to look at synthetic division. So we're going to put, so because this is negative 1, we're going to put the opposite sign. So 1. Our coefficients of this polynomial are 1, negative 3, negative 6, and positive 8. When you're doing synthetic division, you bring the first coefficient down, multiply. 1 times 1 is 1, and then combine. Negative 3 plus 1 is negative 2. Then again, multiply. 1 times negative 2 is negative 2. We put this here, and then combine. Negative 6 and negative 2 is negative 8. Then multiply. 1 times negative 8 is negative 8. And then we get 0. So, what is f of x equal to? Well, it's x cubed minus 3x squared minus 6x plus 8. But we know that we have x minus 1 as a factor. And now that we did division, we know that the quotient is also a factor. So what is this polynomial? It's degree exactly 1 less than this, so instead of degree 3, it's degree 2. So it's 1x squared minus 2x minus 8. So x squared minus 2x minus 8. And we factored this into this successfully. However, we can still, it's not completely factored, and that's what we're trying to find for this problem. We're trying to find the full factorization of f of x. But we've only found x minus 1. This is a linear factor, and what we want to find is this, x squared minus 2x minus 8. So what can we factor it into? Well, now we're to a trinomial, and we have some methods. What are two numbers that multiply to be negative 8, that add to be negative 2? Well, x minus 4 is one of them. And then, or minus 4 and positive 2. Negative 4 and positive 2 add to be, or multiply to be negative 8 and add to be negative 2. And these are a bunch of linear factors. This times this times this, that's what it means to be factors. And this is a full factorization of f of x. This concludes this lecture.